sample and take note to take a look at the side. Diri ka sa kilid matanaw so that it will not break, no? Kay kung malaba ni siya ang aton objective, it will touch the glass slide and the cover slip, it will break, no? The glass slide. Okay? So, ang pares ang ating coarse adjustment knob is your low power objective. Remember, for coarse adjustment knob, you have to use the low power objective. Okay, another one is this one, the smaller knob. Just below the coarse adjustment is your fine adjustment knob. Okay, so what is the function of the fine adjustment knob? The fine adjustment knob is used to adjust the sample when you are using the high power objective. Okay. So, kung gusto mo gamitan ang high power objective, you have to use the fine adjustment knob. Okay. So, if, say for example, you can't see your sample, you can barely see, it's very blurred, no? With this low power objective, what you're going to do is to transfer this, you rotate this into high power objective, and then you manage to adjust, no, until such time that your view under the microscope is very clear, no, and illuminated the sample. Okay, next is, well, here the diaphragm. The diaphragm, this one. This is your diaphragm. Just below the stage is your diaphragm. Okay. Okay, so this is your diaphragm. It closes and open. Oh, it's so dirty. I'm sorry because I just got this from the laboratory and we're not using this for almost a year. So here is your, what you call the diaphragm. It closes up. Look at that. Okay, it close, open. Close, open. Why? Why we are going to close and open this? Okay. The diaphragm is used to regulate the light that is coming through from the outside environment, just like here. Okay. It is the mirror that reflects light to the diaphragm. So what you are going to do, if you see that your sample is barely illuminated, though hindi siya balado, blurred siya, though madulong, no? So what you're going to do is you open this, you open wide this sorry. Okay, so this is your mirror. Your mirror, you may detach this mirror. So you have here the concave one and the plane one. Ang concave ang gapaamon na siya ho. This is the plane one. So ang concave, para more light will be reflected to your sample. So you have to gather light, okay, and then reflect it to your sample para makita mo Diyos, okay, it's already so I will use this low power objective. So it clicks and then adjust this. Look at the side. Okay. So if it is dark, you find some source of light outside or from the bulb. Yes. And then if you see it's very clear now, bright and clear. So that's the time that you are going to adjust now your sample and to find the sample. Okay. This one is the inclination joint. If you want to tilt your microscope up and to its position. Okay. So this is applicable only if you are using the sample or the specimen that is dry. Okay. If it is wet, do not use this. Why? Because some water will spill at the side, no, and it will eventually develop rust, no, at the side of the microscope. Okay. This one is your base. So this is the biggest part, the base. It holds the body of the microscope. Okay? Okay, all the weight of the microscope is supported by the base. So the work of the base is for support Okay, support the body of the microscope. So here is your microscope. It is a very interesting tool in science. Actually, when we're dealing with biology or the study of life, this tool is very helpful in any way, no? From the smallest part, from the smallest, what is this, organelle of our body, okay, to the lungs, up to the organ system, from the cell, tissue, organ, and organ systems. You may use this one, no? This also for the plant, no? For our grade 7, on our next video, I am going to show you on how to make a wet mount using letter E, and how is letter E being described and being seen under the microscope. Actually, if this is your letter E, with your naked eye, makita mo sa mata mo, this is your letter E. Under the microscope, it is inverted and it is very big because it is being magnified. No, dako-dako na siya, and then it looks like this. It is inverted and it is upside down. Ang upside niya, ari sa dalong. So this is for your naked eye. This one, for the microscope, it looks like this. Okay? And how are you going to know if you want to know the magnifying power of your microscope? So you have to look at the eyepiece. This is your 15 times. So 15 times multiplied by the number of, or the magnifying power of your used objective. At this moment, I'm going to use the 10 times or the low power objective. So 10 times multiplied by 10 times. This is your eyepiece. And this is now your LPO. So multiply that. You copy the X. 0, 0, 5, 1. So you have now your 150 times. So this is your magnifying power, or the total magnification. Meaning, you just enlarge your sample up to 150 times. Okay. So kung 40 times na di siya, i-multiply mo by, from here, for example, this is 10. Your eyepiece mo abi, 10 times. And this is your HPO. Just multiply that. 0, 0, 4. So, you are magnifying your sample, or you are enlarging your sample up to 400 times. See? Na kung paano niya gin-enlarge ang aton very, very small samples which cannot be seen by our naked eye. And sometimes we just don't know this bacteria or these organisms are just in the air, no? But the microscope, no, could see that, no? And I mean, the microscope could facilitate these things possible for us to see under the microscope. So, if you have any questions, don't hesitate to message me or PM me if you have any questions regarding the parts, the functions of the microscope. And then next time, I will show you again the on how to manipulate the microscope. We're going to observe the onion, no? Onion. Actually, hindi nyo man makita ang onion, kung ano gid ang itsura sa onion cell. But I could teach you on how to do it. Para if there is now face-to-face interaction during your grade 8, you can now, it is now very easy for you to do it. Okay? Okay, so good luck guys, and see you in our next video. Have a good day.